right, everybody, welcome to Traits and Reproduction Lesson 1.5, Investigating Proteins and Traits. We are learning some new things today about our spiders and about the different proteins that they have. So let's go ahead and start off by looking at our warm-up and answering some questions here. And let's look at some of this new evidence that we have. New information. Dr. Satari and the genetic researchers at Bay Medical Company have determined the proteins of each spider offspring. So now we know the proteins that each of the spider offspring has. We've been working with proteins. We've been looking at how the structure of proteins ultimately determines the trait of an organism. So now we know, hey, what are the silk flexibility proteins that each of these spiders has? Yeah, something like that. And look, we noticed that these were the proteins that we saw in the sim, these types of proteins. We labeled them as proteins 1, 2, and 3. And so we can see, okay, offspring A makes these proteins. Offspring B makes these proteins. Okay, they're different. Offspring C makes these proteins. They're the same. And offspring D makes these proteins. They're different also. So the genetic researchers at Bay Medical Company are interested in spiders with trait for medium silk flexibility. They think this silk can be used for medical purposes such as making stitches, awesome, and for creating artificial tendons. Why do you think offspring B has the medium silk flexibility trait? Here's offspring B right here. Why would they have medium silk flexibility? Well, you're going to answer that right here. Think about that question, answer it in the box, and then come on back to me. Okay, let's revisit these claims that we had about Darwin's Bart spiders, and let's see if we can, do anything with these claims. Can we prove any of them? Can we disprove any of them? Here they are. The question, why do traits for silk flexibility vary within this family of Darwin's Bart spiders? We saw that the parents have different traits than the offspring. Some of them have the same, but some of them are different. They don't all have the same trait. The first claim, claim 1, the offspring have mutations that affect their traits. Okay, I've heard of mutations, right? It's when, like, you get knives that come out of your fists, right? Oh no, that's different. Claim 2, the offspring's traits depend on which parent the offspring received more traits from. Okay, that makes sense. Like, you get more from this person, so you're more like that. Okay, I get it. Or claim number 3, the offspring received different combinations of traits from their parents. Okay. Can we really prove or disprove any of these yet? Not really. So let's go back to our family tree, and it is kind of hard to really say that, we don't know. I mean, number one, it's hard to say because we don't know what proteins the parents had, and we don't know, how those got passed on, if those even are things that get passed on, and so we still come to this question: why do we think offspring has a trait for medium silk flexibility? Well, we know that it's because of the two proteins. It has to be because of these two proteins. We know that the proteins determine the trait ultimately. And so it has to do with these proteins. So here's our next key concept. Organisms can have different proteins in their cells for a particular feature. Different proteins in their cells, just like offspring B. Offspring B doesn't have the same protein. Offspring A has those two similar proteins. Offspring C has those two similar proteins. But offspring B and offspring D, they both have different proteins in their cells. So that is a key thing. Organisms can have different proteins in their cell for a particular feature. Guess what we're about to do? We're going to jump into 7. We're going to mess with that a little bit. It's going to be fun. So this is activity 3 in our lesson. So all the way over here. And we're going to be filling out some information. We're going to be filling out some data tables. Here we go. We're going to do this first one together, Greg, silk flexibility, but make sure you launch the Traits and Reproduction sim, use the sim to investigate how proteins affect spider traits, then record your results in the data table below. So let's walk through this first one together. Here we go. Previously, you used the sim to compare spiders with different traits for the same feature, right? Like same feature, like what did we say? Bristles, did we do that one? Some had a lot of bristles, some had no bristles. We observed that spiders with different traits had different proteins in their cells. We have learned this, that proteins determine the traits. Okay. This time, you will use the sim to add different proteins. Did you know you could do that? Did you know you could throw proteins into the cells to see what happens? Add proteins to a spider cell and observe how that protein affects the spider's traits. First, let's look at an example together. Greg. Let's look at Greg together. Here's Greg. Here's Greg. Where's Greg? Right here. First one, yellow spider. You know what? Let me launch the sim for us. Great. Let's go ahead and fill out that first box right here. It says, what traits and proteins does Greg have for the silk flexibility feature? Okay, here's Greg. Let's click on silk flexibility. And okay, the trait is low. So he has low silk flexibility. And it looks like he has protein number 1. Protein number 1, low silk flexibility. That's what we're going to write down right here. What traits and proteins? Low flexibility, protein number 1. Do you think that adding protein number 1 will change Greg's trait? Why or why not? Well, what we're going to do is we're actually going to grab protein number 1 down here, and we're going to throw more of it in the cell. Do you think that that is going to change his trait? We're going to keep an eye on his trait right here and see if it stays low or if it changes. Now, before we do it, make a prediction. What do you think is going to happen, and why or why not? So if he has a lot of protein 1 in his cell, is that going to change anything? Lastly, let's test. Did you observe a change? If so, record the new trait you observed. So let's go ahead and do this. Let me show you how. I'm going to grab that protein. I'm going to put it over in this little circle, and boom. And look at this circle. That shows that the protein is in the cell right now. What do we see? Does the trait change at all? Nope. The trait does not change at all. It looks like, yep. We don't see any change in the proteins or in the trait. So that's what we would write. We observed no change by adding protein number 1. Okay. So you're going to do this with Greg again, but you're going to add protein number 2. Okay. Then you're going to change spiders. You're going to go to Ruby, and you're going to do this for body color and follow the directions, answer the questions. What traits and what proteins does Ruby have for body color feature? And make sure you add the correct proteins that it's asking you to. And then you're going to go to Otis, and you're going to do stripe color. Again, same procedure. It tells you which proteins to add, and you're looking for changes, if any. Okay, so go ahead, conduct those experiments. Make sure you make your predictions before you conduct the test, and then come back to me. Here are some key things to review now that you've completed the whole table. What did you observe? Why did some traits change after protein molecules were added? Sometimes they changed, sometimes they didn't. And in the sim, most changes to the spider's traits were temporary. Why was it only a temporary change? Why was this not a permanent change to the spider if we threw some proteins in there? Okay. Last thing, while new proteins can be added to an organism, adding one protein to a single cell would likely not change the trait in the entire body of the organism. So just to be clear about that, we're changing one single cell. It's probably not going to change the entire trait. However, we're using this as an example, as a model. It helps us to see how proteins do affect traits. But if we wanted to change a trait, we'd probably need to change the proteins in all of the cells, not just one, just to be clear. Activity number 4, write and share, human muscle protein. There's more. We're not just interested in spiders, we're interested in humans too. Remember, you are in the role of student genetic researchers assisting Bay Medical Company in learning more about the Darwins Bart spider's traits for silk flexibility. However, we just got this letter from Dr. Satari. Let's take a look at it. Let's read it together right here. To student researchers from Dr. Ada Satari, lead scientist at Bay Medical Company, subject research on human muscle proteins. At Bay Medical Company, we are working on several projects. So far, you've been helping us with our spider silk research. However, we now want to introduce you to another project. One of our teams is conducting research on human muscle proteins. I want your team to take a look at the initial findings from their work with a protein called actinin 3. Everyone say actinin 3. Actinin 3 protein molecules connect muscle fibers, helping them contract more rapidly. As a result, the researchers think this protein might help people run faster. The researchers want to know what you think about the results of a test they just completed. They wonder if they should continue investigating this protein. Oh, well, this is interesting. There's actually 3 tests here that we are going to look at, and you're going to make some observations about. If we were in groups, we'd put you in groups of 3, and each person would read just one of these. But hey, you know what? It's not a lot. You are going to read the test, read the evidence, and then answer the question. So for each one of these, go to 2, 3, and 4. You can write something pretty brief. It doesn't have to be a long essay, but just give me some feedback, some observations. Make sure you answer this question. Do you think that this evidence shows that the actinin 3 protein determines running ability? Explain your ideas using the words protein, trait, and feature in your response. Okay, so there's 3 results for the tests right here, and then answer each one, and then we'll move on to the homework. Homework is pretty basic. We're actually going back to the anticipation guide, and you are maybe changing your answer, maybe not. So review your original response to this statement from the anticipation guide. Maybe you remember this statement. Traits such as your hair or eye color are determined by the proteins made by cells in your body. What did you say? Go back and look at it. What did you say about this statement? And what do you think now? Do you agree? Do you disagree? What evidence supports your ideas about the statement? So give me a response there for whether you currently agree or disagree. And then, of course, as always, the self-assessment. No, it is never optional. Make sure you do the self-assessment. We're going to be coming back to these questions again and again, or these prompts again and again, to see how our understanding is changing. And hey, after you've done that, we're done, and we'll see you next time.